to midnight, which is 24. So what we want is to map it from well, there's no reason we can't just map this anyway. So what we want to do is basically map like a negative value over to this thing, and then we can do it. So alright, so time of day, how much time we have is going to be I guess we could do a break, do a branch. So if time of day is greater than or equal to what? Moonrise? Then our kind of our value is going to be it's going to be time of day. We're going to subtract the moonrise from time of day. And then we need to divide that by we need what moon? Yeah. We need another subtract here. It's going to be 24 minus moonrise. And then we need to add we're going to add the moon set. That's going to be our total time. So it'll be time of day minus moonrise divided by, and this is the total DT for nighttime. Yeah, we're just going to do phase percent here. Set phase percent to that. Otherwise, the phase percent is going to be different. The phase percent is going to be the time of day, and then we are going to add this time to that time of day. And then we're going to divide it by this other value, like that. Alright, so that's going to be our phase percent, and that's what this was computed for us last time. So we can hook in all of this stuff to the end here. So it's going to be this phase percent. I guess we just can chuck this right in here. I guess we have to do a get phase percent here to not copy paste everything. So phase percent will be from 0 to 1, so this will normalize it towards, this will go from negative 0.5 to 0.5, then negative 1 to 1, and then the rest of our stuff will naturally fall into those categories. So that'll set our vector properly during the nighttime. So let's see what it does. So night comes up. Not seeing it. So phase percent, current value. Alright, so let's see. Time of day is 20. So moonrise minus this subtraction is going to be 20 minus 18.5. And moonrise, alright, so that's going to be like 2, right? Yeah, 2.3. This will be divided by 11, so it's moonset is 5.5, moonrise is 18.5. So there's 11 hours. So we divide it. The current value is going to be 0.21. So we're going to be 21% of the way through. So we step into, so phase percent is 0.2. So this value is going to be negative. We're going to multiply it by 2, which gets 0.57. Multiply it by itself. So we got 0.32. So it's going to go 0.67 multiplied by that. So with the height angle is 8 minus 5. So the phase height is going to be all these things. So let's see. Phase width is negative 11 and phase height is 3. So it should be negative 11 and 3. Which should totally do what it's supposed to do. Okay. Well, then why aren't we seeing the moon? Alright, so let's set this thing at 0. This is interesting. Why are we... Oh, here we are. We're not hooked up on our final thing. We're computing everything, and then we're not actually setting our celestial vector to the proper thing. Alright, that makes sense. So the moon comes up and over, like so. And then the sun comes up and over. And the stars, alright, the stars are working properly. They don't fade out, they just disappear. So that's something. Blah, nighttime, all the math. Gosh, I'm starting to kind of run out of steam in terms of energy. So we've got these transition periods, so we can start, messing around with them. So why don't we start messing with them a little bit more? So when the sun sets, we're going to go from, nighttime, daytime out to nighttime. So it needs to go we need to set the star brightness and everything like that. We need to go set all of these, pretty much, is what needs to happen. So if we're setting, then the percent difference is going to be what? The time of day minus sunset? Or time of day minus sunset divided by transition time. So it's going to be time of day, subtract the sunset, and then we're going to divide by transition time. And that's going to be our percent finish. So we're going to go from 0 to 1. Do I have my math utils for interpolating nicely set up here? Let's take a look. Yeah, we've got lerp ends and lerp float, start end percent. Yeah, let's do that. So we're going to go from we're going to go from full celestial glow to no celestial glow. Alright, so we'll set the celestial glow there. We need another lurk float. Which is going to start at our halo brightness and go to 0. I guess we don't have any halo brightness, so it's always 0. I'll think about it. We kind of want to, like, the setting sun. Yeah, the transition time there is going to come into, okay, so, yeah, the halo brightness should go from start to end and all that stuff. Let's see, what are we doing up here? Actual halo brightness, we're setting to 0. Alright, so we can just ignore this then. So set that to 0. Actual star brightness, we do need to interpolate. And same thing for the cloud brightness. The cloud brightness is always going to be the same, so we'll just keep setting that one. Alright, so let's see, star brightness. So we'll end at that and we'll start at 0. And the percent is our percent right here. Okay, so the sun setting should have the stars appear in the sky and should have the celestial glow go away. Early night should just do nothing. You have landscape grass type generating collision on my nav mesh? What have you done wrong? So you made your landscape grass. Also, good morning, Calvin. Hopefully you're doing well. So I think how the grass landscape stuff works is if you're using the stuff where you paint on the different types of grass or whatever that you want, and then it spawns it for you. I think it's spawning everything that you set up in your grass object to spawn. So like when you went into your your test grass thing or your grass object itself, you're actually having it spawn a grass mesh. And I think that's going to have stuff on it. So it's probably something that has to do with these objects being spawned that is adding it to collision. So there's going to be something there, which is giving you problems. I don't see anything that has to do with. Do these meshes have collision settings on them? Oh yeah, so these meshes have collisions set on them right there. So I don't see anything in the grass here that lets you set any collision settings. So what it's probably going to do is it's going to spawn that object using your default settings. So whatever your collision preset is, it might just use that as opposed to, you know, nothing or whatever, which kind of sucks. I should actually boot up this thing. Like the collision on my stuff here, I don't see any collision being generated on the grass. Just on all this crap in the background. Maybe I should disable all that. I thought I had. It's only affecting some of them? Well, maybe those meshes have default collision for the grass. If it's not, then, you know, it might be something else. The grass spawning stuff, as you saw, if you were here last time when we actually cracked it open and fixed some bugs in it, obviously it's not super amazingly finished. So yeah, that's a thing. Alright, so let's see. Our sunset should fade in our stars. Let's see if it does. So fade in. Yeah, it was real quick. Alright, early night. We'll set our star brightness. So now we need to do the rising of the moon. Alright. Well, I'm not an expert on the nav mesh stuff. I'm not using nav mesh for anything, so I'm not the person to ask for that, unfortunately. So I can't tell you the intricacies of how the nav mesh is constructed. It may be, you know, there's something in there that dynamically adding those objects adds them to the nav mesh or something. Alright, so rising of the moon. So the moonrise is basically going to be time of day minus moonrise. Is going to be our percent. Yeah. Alright, so what we're going to do is we're going to go with the celestial glow. We're going to end at that, and we're going to start at 0. And we'll set our celestial glow to that. Our actual halo brightness should also come larger. Yeah, our star brightness should be set as normal. So let's just do a lerp here on our actual halo brightness to bring that guy into the fold. Let's see, halo brightness. So it should end at that, it should start at 0, go to that, and that's our percent right there. Actual celestial glow, actual halo brightness. Alright, cool. Alright, so let's do our moon set. So that's going to be time of day. It's going to be time of day minus moon set for this math equation. Alright, so we snag that. We're going to be lerping our celestial glow. Yeah, it's basically going to be this stuff right here. It should go to 0. Our actual halo brightness should go to 0, not start at 0. So it should do that, and then our star brightness should also go to 0. No, our star brightness should stay as it is. Like so. So during the moon setting, the celestial glow will go to 0, the halo brightness will go to 0, but the stars will remain out and so will the clouds. Alright, so early morning should be just set like that, just the same, and then the sun rising, the stars should go to 0. It's basically the opposite of this. Or let's see. Yeah, it's basically the opposite of this. Alright, so it's going to be time of day minus sunrise, I believe. Divided by our transition time. Celestial glow is going to end at 1 and start at 0. Come on, let me pick that. Halo brightness is definitely at 0. And our star brightness is going to start at star brightness and go to 0. Did we not hook that up here? No, we did not. Cloud brightness will stay the same. Okay, so our sunrise and sunset and everything like that should happen properly now with some things. Of course, the color of the sky and all that is not going to change, but whatever. So that's our sun. Stars come out, and then the moon comes up. And the stars go away. Ooh. That was pretty nasty. So let's see, what was that problem? It was 0, 5.5, 5.6. Six, 5.5, 5.6, 5.7, 5.8, 5.9, 6.0. Alright, so like 5.6 or 5.7 should actually have the celestial glow going from, you know, the moon's setting. Should start at 0. It's time of day minus moon set divided by transition time. So time of day should be like 5.5 minus moon set, which is 0.2. And that should give us our percent. Alright, well, let's log it out real quick. Alright, so the celestial glow is 100. Okay, so that's not really working out how I want it to. So that's why it's not. It's interpolating as you would expect it to. So why are the stars immediately going out is the question. So the star brightness is set to start at this and end at 1, and that's not setting properly? Or is it not running? Alright, so we're supposed to be at like 6.0, 6.1, 6.2, 6.3, 6.4, 6.5, and 6.4, the stars It's frustrating that you can't actually debug this stuff when it's These effects are starting to look like the picture. Yeah, well, we're getting there. It's a slow process at times. I wish I could actually debug blueprints inside of the construction functions. Instead, I can only do printfs. Start brightness is 0.9, supposedly. So, alright, so 6.0, it gets set to 6.1. Start brightness is set to 1.62. What? And 6.2, 6.3, 6.4, 6.5. Is something wrong with my math here? Alright, so if we do 6.4, percent is negative 0.02. Okay, so there is something wrong with my math. So it's time of day minus sunrise. So let's take a look at this a little bit closer. Time of day is less than sunrise minus transition time. So it definitely should be time of day minus sunrise. No, it's the other way around, isn't it? It's sunrise minus time of day. And this is we're going to have another one here where moonrise is greater than this, so moonrise should be swapped here with this guy. Alright, so 6.0, 6.1, 6.2, 6.3, 6.4, 6.5. Alright, so it should go 6.0, setting a moon. Alright. So 6.1 should say start brightness is set to 0.18, percent is 0.8. It's supposed to start at 0.9 and end at 0, and it's saying star brightness is 0.18. I must have something wrong with my alert float. How? It's percent times end minus start plus start. So 0 minus 0.9 plus 0.9 multiplied by percent. What? Alright, percent is 0.76, end is at start is 0.9 plus start, so 0.76. It's 0.39. The percent was 0.5. Alright, that should transition out, and the stars are in, and this thing comes out. What the fuck is going on here? I don't get it. Is it order of operations? If the percent sunrise minus time of day. Alright, so it's 6.1 or 6.4. The percent is 0.2. It's inverted. Yeah, it's not sunrise minus time of day. It is sunrise minus time of day, but it's... We need to invert it. It's 1.0 minus this. Like so. I'll need to do the same thing up here. Alright, it's better. Alright, 6.1 should have stars, 6.2, 6.3, 6.4, 6.5. Yeah, alright. stars come out, this thing comes out. Stars go away and the sun comes out. Let's also decrease the size of this texture real quick and re-import it so we don't get that awful stretching. So let's set our time of day to midnight, and we should be able to re-import our spectral halo. How come it's still got this weird clamping issue? Alright, so let's see. We need to get this skysphere thing here. We want this weird clamping crap to just go away. So it's not a texture setting. So let's go to our material real quick. Like, we clamp this from 0 to 1. I mean, do I need to just scale this whole thing again just to mess with it one more time? If I just do that, make the texture smaller and re-import it. Yeah, it needs more space in order to not freak out and have lines everywhere. Alright, so we're definitely getting a lot closer to having it look like it should. Like, we don't have our sky map in there for the background, but that's fine. We at least got our stars and all that starting to come together, starting to actually be, you know, like an actual sky sphere sort of thing. Alright, and we need a background switch for that cube map, something like that. We need a sky to come in and actually, you know, do something. I mean, should we just have a blue sky come in? Should that just be a thing that we do as a kind of a a horizon color and all the other stuff that they've got. Because they did that with colors for their basic sky sphere. They didn't actually do anything nuts. So I mean, that's what we could do, is just put in an actual color and then basically flag it on and off for the cube map for this thing right here. So we're going to call this something other than zenith color. I'm just going to call it sky color. And it'll be blue. And I guess we want like a day-night percentage change, something like that, to go from like, well, the background should be this color, transition to this other color. So what it would be some sort of multiply, and then an add. And that would go over there. And we would have our, let's see, background weight, default value of 0. And we need a subtract. So it would be 1.0 minus this thing. Like so. So if the background rate was 1, then it's blue, and if it's 0, then it's not blue. So when we call it day weight. Alright, so we're going to want our day-night cycle needs another float, which we'll call day weight. And this is going to default to 0. Alright, so let's do